Today we're going to talk about our duplicate GE 1.5 top box and SSB pitch system. Our start procedure for our top box is our 1F1, which is our main breaker, and then our 6F1, which controls our PLC. We have a light switch on the top for 2 overhead lights. Our 6F2 is our main DC power for the SSB box. Our 2F1 is our main AC for the SSB box. Our 1F2 and 1F5 are our main breakers for our VFDs. We've got 3 VFDs on the bottom that are either controlled by our E-box. Our E-box is controlled by our PLC. We have 2 power supplies on the top over here with 1 transformer. We have 2 heaters on the bottom and a fan on the side. 2 P2100s which control our heaters and fans off temperature.
120 K line.
And the 3 VFDs just clicked on right there.
So this is our access cabinet controlling our SSB pitch system. In here it's all motor controlled, motor starter controlled for our 3 pitch motors over here that simulate the pitch motors would be in a GE turbine. They have limit switches that control them for pitching up to 90 and pitching back down to 0 to full run. And then in this box we have a heater and a fan that's PT100 controlled by our PT100s through the PLC in the top box. This whole box is PT100 controlled.
So now we're going to talk about the battery box. First of all, it has a heater, a PT100, a fan. It also has an e-stop on the top here. The F1 has 3 breakers. The F1 breaker controls the battery charger, which is right here. And the F2 and F3 breakers control the capacitor. And we also have a transformer underneath and a choke up here on top. The transformer goes from 208 to exactly 90 volts. And then it comes up through these diodes here, but how they're set, we have them set in series. And pretty much when the voltage comes in one side and it comes in the other side, positive and negative, turns this into a rectifier. Then from here it goes to your capacitor, which is capable of holding 400 volts, but for this scenario we only need it to hold 90. So anyways, we have our amp meters over here, which the DC amps up top here will tell us how many amps or volts are being held in the capacitor inside here. And then we have 3 more gauges for each pitch motor over there, which will tell us how many amps is being pulled. So technically, the whole purpose of this battery box is in case if the turbine faults, it'll run on battery power to pitch the motors back to 90 degrees without having any damage done to the turbine.
Alright, so we're going to show you our pitch motors, our 3 big motors here on the side, and I'm going to talk to you on how our start, stop, automatic and manual go. So right here are our 3 pitch motors. We've got limit switches up on the front. And then over here we've got our 3 big motors. Our first one is our gen fan. The second one is for our gearbox cooling fan. And our third one is our big motor, which is our gearbox oil pump. And then on our battery box and top box, we have our manual and automatic. And we have a start and a stop and an e-stop on the top side. So in manual mode, our capacitor charges up to 90 volts. And if you hold start, as you can see, our 3 motors are going forward and our 3 big motors are ramping up the speed to 60 hertz. And if you press stop, you hold stop, they pitch back, and our 3 VFD motors shut off. And if you hit a limit switch, it stops the motors. And then in automatic mode, 3 VFD motors start, our 3 pitch motors start as well. Our limit switches do stop the motors. And if you hit an E-stop at any time, it shuts all the motors off besides our 3 pitch motors, and our 3 pitch motors are now running off our battery supply, pitching back. 1, 2, 3!